let me turn the projector on and then we will be good to go. Okay, section 10.2. This is going to go pretty quick. So let's put away that previous section. We'll finish that, but some people are done already with that, and so we need to carry on. Yes, 10.2. This is going to begin on page 695 of the big book, or 10.2, begin on page 512. 512 of the paperback book. So we skipped a whole bunch of pages. Yeah, go ahead and put that previous section away. I need you to pay attention to this. Otherwise, this homework is not going to work for you. But this is probably going to be the easiest homework of the semester. As long as you pay attention right now. Yes, this is not hard. This is not hard. But we have three basic definitions that are going to happen here. 10.2 is talking about parabolas, 10.3 is talking about ellipses, 10.4 is talking about hyperbolas. So we need the definition for each of them. We're combining them all together. They're really simple, and we're just going to do some basic graphing for these. It's not hard. Okay, a parabola is a set of all points in the plane that are equidistant from a fixed line. The line is called the directrix, and the fixed point is called the focus, and it's not on the line. Parabolas, we know what they look like. They can open up, they can open down, they can open left, or they can open right. So parabolas, we know what they look like. They're just defined to be these points that are equidistant. And this was actually the original definition used for parabolas. And finding the equations for these was rather tedious because they actually literally picked their points in their line, their focus. And so the focus would be, you know, someplace up here or someplace over here. It opens around the focus. And then the directrix would be the same distance away. And then they'd solve the equations so that their distances were the same. This is very tedious to do. We're not going to do that. Just recognize that that is a parabola. An ellipse is a set of all points whose sum of the distances from two foci is a constant. So if you're looking at ellipses, they're like eggs. You have your two foci. Think about putting thumbtacks at your foci, and you have a string going around your pen. You can kind of trace it around. You know, if you had a spirograph set growing up, you had that ability. You put your two thumbtacks in there, you can draw ellipses. They can be horizontal or they can be vertical. Those are our two foci. Ellipses are actually used in buildings and stuff like that, because you can, if you want to make the sound project it to a certain point, you can use an ellipse to do that. There is a story that was told in the original signers of the Civil War, when they were working out the end of the Civil War, that the president was standing at one foci, and he always stood there because from that point he could hear the conversations of everybody else in the room. That was all concentrated down to right there. And so he never left there. And I went on a history tour to that building. And if you stand right there in that one spot, you can hear everybody else. Or again, in the equivalent other foci there, you can hear that. Just outside of Lincoln, Nebraska, they have something that they call the whispering wall. And it's part of an ellipse. And you can whisper from one point on next to the edge of the ellipse, and that will travel around to the other foci around the ellipse, and people can hear you. You're like 30 feet apart, and you just barely whisper something. You can hear it at the other point because it's in the shape of an ellipse. So those two foci are kind of, if you put an ellipse together, those two foci are where the sound and stuff is going to travel. It's used in medicine if they're trying to do directed radiation to something. They'll put the tumor as one of the foci on the radiation machine. So they're actually used a lot, the ellipses. Hyperbolas. Hyperbolas look the opposite. They're like a half ellipse, and they open around their foci. They have two foci, but it's the difference of the distances is constant. The ellipse, the sum of the distances is constant. The hyperbola, the difference of the distances is constant. These guys have different uses here again in science. You can still focus things onto your hyperbola, onto your foci and your hyperbola, but it's not the same. It's not a contained foci. It's for projection purposes. Okay, so what do these equations look like? We're going to go through 10.2 first, standard equation of a parabola. The parabolas look like x minus h squared equals 4p y minus k. And all you need to know is that the vertex of your parabola is the point hk. And this one is going to have a vertical axis, which means this opens vertically. If the 4p is negative, then it opens down. If 4p is positive, it opens up. If you don't have h and k, if there is 0, then this is a vertex at the origin. And you don't have to be terribly precise on your graphs. You can actually just find your vertex and then know which direction is opening, and you can get your graphs for them. So let's actually do these. Sketch the parabola. I need to put it in standard form. So y squared equals to minus 6x. Notice that there's not a y minus 0 and an x minus 0, so the vertex in this case is just going to be the point 0, 0. This is negative, so is it opening left or right? Left. So literally all you're going to do on your homework is find your vertex and then draw your parabola through that vertex, opening to the left. How hard is that? Question? You got it?
Okay.
If that minus 6 were a plus 6, then it would be opening to the right. So negative opens left or opens down, positive opens right or opens up. It's y squared, so y squared says it opens horizontally. X squared opens vertically. Okay? So this is my point 0, 0. Notice I'm not graphing any other points on my graph, so I'm not actually labeling any other points. There's nothing else to label. That gives me my graph. Let's do another one. This is in standard form. We have the squared on one side. It's an x squared, so is it a horizontal or vertical opening? Vertical. And the vertex is going to be the point 1, negative 3. It's the opposite sign of what you see inside. X values go with x, y values go with y. So 1, negative 3, and it's vertical. So here's 1, here's negative 3, and it's vertical. Opening up or down? Up. Sketch your parabola. Oh, that's horrible. Try again. There's our parabola on it. Does that make sense? Can we do that on our homework? Yes. That's good, because that's all you get for parabolas. Question? Right there?
So
Vertical because x squared.
Yeah.
Up because this is positive. Okay? Standard form of an ellipse. The ellipse looks something like this. It's going to be x minus h squared over a squared plus y minus k squared over b squared equals 1. The center is going to be h and k, and that's going to be important to us. And then a squared is always the largest value. A squared is always the largest denominator. Here, notice I put the a squared under the y. That says you're going to have a vertical major axis and the other one's a horizontal major axis. You don't really have to worry too much about that because I'm going to show you how to sketch these without knowing that information. All you have to be able to do is find the center. Once you find the center, the sketch is really, really easy. So let me show you how to sketch these. What is the center for this one? Yep, it's always the opposite sign. So let's go graph our 2, -1. Now, look under x. X has a 4, so the square root of 4 is equal to 2. So I'm going to go left and right because x is left and right. And I'm going to go left and right 2, draw my dot, draw my dot. And then y has the 9 under it. Square root of 9 is 3. That's y, so I'm going to go up and down 3 from the center. 1, 2, 3. 1, 2, 3. And then draw your ellipse around it. Up and down, the square root of the amount under y. Left and right, the square root of the amount under x. That's all you need to have to be able to graph it. I'm not going to ask you to find the vertices. I'm not going to ask you to find the a, b, and c values and all of that. I just picked the graphs for you, and that's all I'm going to ask you to do on the test. Sketch the graph. So left and right, up and down, the amounts and the denominators. Let's do another one. What is the center for this one? Okay, and what do we go left and right amount? 3. Left and right 3. The square root of 9 is 3. So left and right 3 from your center. And then up and down how much? 2 from the center. And then draw your ellipse.
So the first fraction always says left and right, and the second one always.
No, it's whatever is underneath x is left and right, and whatever is underneath y is up and down. And they can switch the order of that. They could do the y's first and the x's second. But it's whatever is under x is left and right, whatever is under y is up and down. Can we do that on our homework? Section 10.3 done. Section 10.4, hyperbolas. Notice the only difference between the ellipses and the hyperbolas is that minus sign. Here, a is a value, a squared is in the denominator, in the first denominator. That really doesn't matter to you, but if you're trying to figure that out, a squared is what is in the first denominator, the positive one. Don't worry about the center, foci, and asymptotes. I'm going to show you how to sketch all of that. Here again, it's all based off of the center. This is more, oh, you need this for one of, you have a fill in the blank question. It says the eccentricity of a hyperbola is given by this equation E equals C over A. You need that for one of your, you have a fill in the blank answer. You're going to need that for your eccentricity. And the eccentricity simply is a measure of the ovalness. And the same thing is true in ellipses. It's a measure of the ovalness. How bent is it? So on your hyperbolas, how steeply bent or how wide it opens. That eccentricity gives you is a measure for that value right there. Okay, let's graph some of these. Oh, I have to tell you about this too. If E is bigger than 1 for parabolas, and we really don't care about that. When E is very large, the branches, sorry, for hyperbolas, the branches are nearly flat. When E is really small, the branches are very close together. So very large values, like 1,000 or something like that, you're going to have something that's almost a straight line in your hyperbola. And like 1.1 or something close to 1, then you have something that is more narrow. And I believe that's also one of the questions, fill in the blank questions on your homework. So you'll need that. Let's graph. This is what I've been wanting to do. What's the center? -1, -2. Here's the center. Just the same method we did before. So left and right, how much? 3. And then up and down, how much? My scale is 1, 2, 3, 1, 2, 3. My scale is off. Oh well. Up and down 2. Now we have to draw a rectangle through these. Let me get a different color pen. I'm going to make my rectangle red. Draw a rectangle through these so that the dots we just drew are the middle of the sides of the rectangle. Middle of the sides of the rectangle. Then I'm going to draw dashed lines that are diagonals of the rectangle. And then the x squared term is open, it is a first term, so it's going to be opening horizontally. It's going to be opening left and right. So I just draw it so it approaches the asymptotes that we sketched. And you draw it in a hyperbola shape. That's how you sketch a hyperbola. You have to sketch that box, draw the diagonals so you know what the sides are approaching. Question?
So you would draw it like on this side because it's positive, like because you can draw up and down too, right? You can draw it, like,
No, you have to go left and right. What's under X?
no, but I'm saying that, like you drew
Oh,
the
yeah.
outside.
If those had been switched, then I would have drawn up and down.
Okay.
If the Y value's first, then it's up and down. X value first, it's left and right. And you don't worry about that for ellipses, just for hyperbolas. So let's do the last one. What's the center?
When did we switch?
Oh, yes. We read them backwards. 2, -1. And then up and down is it's under Y, so how much goes up and down? 3. So 1, 2, 3. And then left and right, 2. And then remember, draw your, wrong box. Draw your box around it. Draw the dashed lines. And then, is it opening up and down or left and right? up and down. Mhm. Y up and down.
Y is first.
That's first. That's correct. That's what I'm looking for on your homework. Can we do that? Is that not an easy ending assignment? Yes, it is easy. Okay, let's go ahead and finish the homework. I have a question for you guys while everybody's here. Do you want to look at the review today and not come in tomorrow? Or do you want to come in at 8 o'clock tomorrow morning to do the review?
8 should be this afternoon, 11.
You owe me till 12.
I still have to meet with my advisor at 11.
Make an appointment for noon.
But this is something that's happening to me.
Well, you owe me till noon. You owe me till you're finished. Do you want to review today or come in tomorrow at 8 o'clock in the morning to review?
Tomorrow.
Tomorrow at 8 o'clock in the morning? Okay, tomorrow at 8 o'clock in the morning. I know, I was hoping to sleep in too. No, I want you guys to have plenty of time to study.
So we're gonna do.
Yeah, we're gonna do the review 8 o'clock tomorrow morning.
How long will that take? Do you think?
30 minutes?
Then, I mean, we could just meet like at 10 or something. We're there like 9 or 9. It's just gonna be 30 minutes, I mean.
9 o'clock tomorrow?
Yeah, it's 9 o'clock.
Yes, 9 sounds great.
9 o'clock tomorrow.
Yes.
9. Just do it at 9.
Let's get it over with.
I want you guys to have plenty of time to study. 9 o'clock.
Okay.
9 o'clock. Okay.
Yeah.
You need to stay until you have the homework finished. That's both the last assignment and this one. I told you it's easy, didn't I?
Yeah.
Yeah.
They blind us to
So let me get this posted online and then